Hello students, in lecture number 11, 12 and 13 we have discussed about the Z transform and the properties of the Z transform, and in this lecture we are going to discuss about the inverse Z transform. We will learn how to convert the signal. So there are basically two methods to find out domain Z transform. One is the power series method, another is the partial fraction method that we will be discussing in this lecture. Right. So first we will discuss about the power series method, and let's start with an example. Right. So let's suppose we are given this function and we have to find out the inverse Z transform of the signal using power series method. Right. So in power series method, what we do, we divide numerator with the denominator using long division method. Right. So dividing the numerator with the denominator, here for example z plus 1 is the numerator and z square plus 0.2 z plus 0.1 is the denominator. So using long division you can actually find out this. Right. We can find out the sequence in the quotient. So this we know that we can continue until we have sufficient number of terms, right, and we can stop there, and then we can find out the inverse Z transform of this. Right. So inverse Z transform of x of z would be simply 0 as 0, which is z power 0 coefficient, z power minus 1 coefficient, and so on. Right. So this is actually the inverse Z transform of function and in this exercise problem you have to find out the inverse Z transform using power series method. The answer is given. You can actually verify your answer after solution. Another similar example, and answer is given for your convenience. Then the second method, which is the partial fraction method. Of course, in this method you have to break your function into the partial fractions. Right. So before breaking into the partial fraction, you have to do some simplifications which are convenient later on. Right. So for example, this is the function that you are given to find out the inverse Z transform. Right. So first what you have to do, convert negative power of z into positive. Right. For example, taking z power minus 3 common from here, z power minus 1, and making it positive. So now the second step would be to make the coefficient of highest power of z in denominator equal to 1. Right. For that you have to take 2 common from the denominator. Right. So first make the powers of z positive. Right. So this is 1 upon z cube, this is 1 upon z, this is 1 upon z square. So take 1 upon z cube common from here, z 1 upon z common from here, or 1 upon z 2 common from here. Right. And then you will get this function, and then make the coefficient of highest power of z in the denominator equal to 1. For that we have to take 2 common from the denominator. Right. Now we have this simplified version of the function which we need to find. We have to break it out in the partial fractions. Now x of z can be further simplified because denominator polynomial can be factorized. Right. So first take a z common, and then the rest of the terms can be broken into these two factors. Right. Now we can actually break this into the partial fractions, but before that let us divide z by either side. Right. And this is also very helpful while using Z transform table. Right. You will see in the next slide that what was the benefit of this. So let us divide z both sides. Right. So x of z upon z, and this would be 0.5 upon z square in the same. Now you have to break it into partial fractions and find out the residues. You can now after partial fractions the sequence would look like this: x of z upon z, 3 upon z plus 1 upon z square, 1 upon z minus 1, and 4 upon z minus 0.5. Now in the next step you can actually multiply z to this side. Right, so multiplying z to this and this. So this function can be further simplified by multiplying z to the right hand side. Right, so multiplying z to the right hand side would give this result. Right. Now either you can write down x of z in this form as a positive powers of z, or you can write down as a negative powers of z. Right, so 1 upon z would be z power minus 1, taking z common from the denominator from this and this, you can write down as a negative power of z. Right, and because next step we are going to use the z transform table, and sometimes z transform tables are given as a positive power of z, or sometimes they are given as a negative power of z. So whichever the z transform table you are using, you can write down your function accordingly. Right, so in the next slide, the function that I am going to use, the table that I am going to use is actually based on the positive powers of z, so we can use directly this. So from this table you can see the z transform of some constant like 1, like we have 3 here. Right, is simply impulse function. Right, so the inverse z transform of 3 would be 3 multiplied by impulse. Right, and this one, the second term, is 1 upon z, or z power minus 1. Right, it is unit delay. Right, unit delay, 1 multiplied with unit delay. So we can simply write down this as an impulse delayed by 1 unit. Right, then z upon z minus 1, you can see z upon z minus 1 is unit step function, so inverse z transform of this would be simply u1, and z upon z minus b, this one, z upon z minus 0.5 multiplied by some constant, right, using linearity property. So inverse z transform of this would be minus 4 0.5 power n. Right, so using this table you can actually write down the inverse z transform in this form. Here is a simple exercise problem for you. You have to find out the inverse z transform using partial fraction method. Right, so answer is given here, and you can actually solve it, and if you find any difficulty you can contact. So that is end of lecture number 14, and if you have any queries you can send me using my email address given on the first slide. Thank you very much.